Hey, what is up guys? Welcome to another video. In this video I'll be going over a particular problem that I first saw in high school and what it taught me about persistence. But before I get into that, I want to welcome any new subscribers. Thank you very much for subscribing. And if you're wondering what this channel is about, I'll mainly be covering GCSE maths materials and things to do with exams. I have created videos on the 6 maths GCSE exams from last year. If you haven't seen those already, check those out. I've done some videos on different GCSE topics, and I'll also be doing videos on general maths topics that apply to everyone, not just GCSE students. Every now and then, like this video, I like to go into problems that interest me in some way, but overall I hope that you can have a fun and educational experience with the channel and we can explore mathematics together in a way that isn't too serious. Okay, enough of that, let's get into the problem. As I said, I first saw this problem in high school and I call it the ant problem. And the reason I'll always remember it is it was kind of like that. If you've seen that Simpsons episode where Lisa Simpson gets that problem on a cereal box, and it seems like everyone else can solve this problem except her, and it really bothers her. This is kind of the same thing for me. Like, I just couldn't seem to figure out the answer to this problem. It took me about a week. For some reason, it seemed like everyone else around me knew instantly how to figure it out. But anyway, the problem says, 2 ants crawl across a table. The red ant started on one side of the table, point X, and the black ant started on the opposite side of the table, point Y. And here we have a diagram where point X is where the red ant started, and he's crawling across the table, and point Y is where the black ant started, and he's crawling this way. On the way, the ants meet. After meeting, it takes 20 seconds for the red ant to reach point Y, and it takes 5 seconds for the black ant to reach point X. So they met at some point on the table and they kept crawling towards the opposite sides of the table. Assuming the ants traveled in a straight line and at constant speed, what is the total travel time of both ants? So if you'd like, you can pause the video now and have a go yourself. I'm going to represent this problem in a diagram firstly. So we have the width of the table, which is the distance both ants have traveled. And this is X over here and Y on this side. And they've met at some point on the table. I'll call this point M, and this is the meeting point. So this is the meeting point. And after meeting, it's taken the red ant 20 seconds to get to point Y. And it's taken the black ant 5 seconds to get to point X. We don't know how long it took them to get to the meeting point, but we do know at that time, the time it took for the black ant to get from point Y to the meeting point, and for the red ant to get from point X to the meeting point, that time was the same for both ants, obviously, because they met at the same point. I'm going to call this distance Y and this distance X. So this is the distance from the ends of the table or the sides of the table to the meeting point. Now the way that I thought about this problem in order to solve it was in terms of ratios. Now, because they're going at constant speed, the ratio of the distances to the times is going to be equal. Let me explain that a bit more. So the speed of the black ant, is going to be the distance he has traveled divided by the time. And we know that the speed of the black ant is equal to this distance y divided by the initial time, and I'm going to call that time it took for him to get from point Y to the meeting point M, I'm going to call that T1. And as his speed stays constant throughout, that is going to be equal to this distance x divided by the time it took for him to travel that distance, which was 5 seconds. Okay, so I have two ratios here that are equal related to the speed of the black ant. Now the speed of the red ant is equal to this distance x divided by the time it took him to travel that distance, which I've called T1. So that the black ant traveled distance y in the same time it took the red ant to travel distance x. And the speed of the red ant is also equal to this distance y divided by 20 seconds, the time it took him to travel that distance. Okay, so I've created some equations here relating the distances to the different times. And what I'm going to do is to rearrange these equations in order to get the ratio of the distances related to the ratio of the times. So if I rearrange this equation for the speed of the black ant, so I can cross multiply, and what I get is the ratio of distance y to x is equal to the initial time divided by 5 seconds. So the time that he's taken to travel this distance divided by 5 seconds is the same as the distance of y divided by that distance. And let me go into that in a little bit more detail because that's the key to my solution to this problem. So let me give you a situation with some real numbers in it. So let's say you walked a distance of 20 meters. Let's say you walked a distance of 20 meters. And you have a constant speed of, say, 5 meters per second. And let's split this distance up into, say, a section of 5 meters and 15 meters. So the time it takes you to travel 5 meters is 1 second, and the time it takes you to travel 15 meters is 3 seconds. And we can see the ratio of the distances, so this distance 15 over 5 is equal to the ratio of the times, which is 3 over 1, which is true. 15 divided by 5 is 3, 3 divided by 1 is 3. So when we've got a constant speed, the ratios of the distances is equivalent to the ratio of the times, which is all I've said here. The ratio of distance y to distance x is the same as the ratio of the time it took that ant to travel those distances. And we can say the same thing for the red ant. So if we rearrange these equations, again cross multiply, so we have that same ratio, the distance of y to the distance of x. What we get here is the time 20 divided by the initial time it took them both to get to the meeting point, T1. And now what I have is the ratio of the same distances to two different sets of time. And so I can make these equations equal to each other. So y over x, the ratio of y over x is the same as that initial time over 5, which is also equal to 20 seconds to that initial time. So if we just focus on this part of the equation, you can see that I can solve this now. So something divided by 5 equals 20 divided by that same thing, and you might see the solution already. We can also solve this algebraically, so what we need to do is to cross multiply. So we take the denominators and multiply them by the numerators, and what we end up with is t1 squared equals 100. So therefore t1 equals the square root of 100, which is 10. Okay, so let's put that back into context. So that initial time it took them both to get to the starting point was 10 seconds. So the black ant took 10 seconds to get to the meeting point and then 5 seconds to get to point X. So the travel time for the black ant was 15 seconds. So what we're going to get here is the total time equals 15 seconds. And then the red ant took 10 seconds to get to the meeting point and then 20 seconds to get to point Y. So overall he took 30 seconds. And then overall for the total time for both ants will be 45 seconds. And that is the answer to this problem. I think the key here is to see the solution in terms of ratios. There are other ways to solve this problem, by the way, but I think this one is the most straightforward and intuitive. So I hope you found this problem interesting. Let me know how you went. Did you see the answer straight away, or did you kind of take some time to think about it, and maybe you came up with a method that was a little bit different to mine, but you still got the same answer. Yeah, let me know in the comments. Leave a like if you enjoyed this video. I might do some more videos like this if people enjoy them. Other than that, I'll see you in the next one. Bye for now.